Continue with section 6.1. We have a couple definitions. Now, a polynomial function is any function of the form f of x is equal to a sub n x to the n, a sub n minus 1, x to the n minus 1, plus plus a squared x squared, plus a1x, plus a0. Now, it looks really complicated, but all this is saying, like, the a sub n things are just numbers. So it's like 2x to the 5th, plus 3x to the 4th, plus 7x squared minus 2x minus 5, stuff like that. So the a's are just standing for numbers, and the little subscripts don't mean anything to them, so don't stress. But basically all it's saying is you're getting whole number powers all strung together with addition and subtraction, right? So that's what makes something a polynomial. Like this one right here, that's a polynomial when we got all done with it right here. That's a polynomial. You've got negative 2x to the 3rd minus 8x squared and so on. Okay, so this is just the math person's way of writing that out in general form. Then we have a very specific one that we're very interested in for the next 2 chapters, which is a quadratic. A quadratic function is a polynomial function which can be put into the form f of x is equal to ax squared plus bx plus c, where a is not 0. This is called standard form, and it's a polynomial of degree 2, right? Okay. So one thing to keep in mind, why is it the whole a cannot be 0 thing? Well, if a was 0, that would cause 0 times x squared, right? And anything times 0 is gone, and it would make this whole term just go away. And then you're stuck with a linear function from that point, right? So that wouldn't be quadratic anymore, it would be linear, what we studied in chapters 1 through 3. Okay, so there we've got that. Now we're going to fill in the table for the general graph of an x squared function and an x cubed function. Okay, so we're going to start with the x squared. We're going to use our calculators to help ourselves just a little bit here. So I'm going to go to y equals, and I'm just going to clear that so you can see what I did. So I went to y equals, and I've got some old stuff in here that I don't want, so I'm going to clear that out. And maybe it'll help if you see the large screen. There you go. So I cleared that out. And now I'm going to type in my function, which is really simple. It's x, which is this button right here, the xt's theta n one right there. That one. Right? It has the word link above it. And then you're going to square it. You can either use the x squared button down here on the left above the log button, or you can use caret 2. Either way, you've got a function. All right, so now I want to get the table because I want the table to give me some points for the table that is in the notes. So I'm going to go here, and I can see, oops, I've gone pressed up too many times. All right, so I want negative 4, I think, is the starter of my table. So I want negative 4 goes to 16, and then 9, 4, 1, 0, 4, 9, 16. All right, so you're going to enter those in over here. So 16, 9, 4, 0, oops, not 0, 1, 0, 1, 4, 9, 16. There we go. Now you plot those points, and then you draw a curve to connect them. Go ahead, take a minute. Pause me. Oops, not there. I actually have the function, and it's right here. Oops, hold on a second. There we go. Something like that. Cool. All right, so that's what the basic function of a quadratic looks like. There should be little arrows at the top here, but I can't draw those with my computer program. So suffice to say that they're there. It keeps going forever and ever and ever. And that's called a parabola, right? Which you've probably seen in some math class before. Right? So parabola shaped for x squared. Now let's look at a cubic function just for our own benefit, which is we have a polynomial function which can be used to draw or can be put into the form f of x equals ax cubed plus bx squared plus cx plus d. All right, so notice it's cubed, right? That's cubic, right, to the 3rd power. So this is a polynomial of degree 3. All right, so now I'm going to go back to the calculator and have it help me with the table. Not that I couldn't do it by hand, but it's so much faster if I do it by hand. Oh, real quick, by the way, did you notice how the negative ones all became positive for the squared one? Right, because negative 4 times negative 4 is positive 16. I bet you that's not going to happen with a cubed. So let's clear this out. X to the, see that, the caret button, 3rd. Enter. All right, so now when I go to the table, because it's cubed, it's not going to work out quite that way because negative numbers are going to give you negative answers and so on. Okay, so I think the table starts at negative 3, so that goes to negative 27. And this goes to negative 8, negative 1, 0, 1, 8, 27. So we've got those points, and now we're going to plot them on the graph. So plot them, and then you draw the curve, and I will pause and be right back with the graph. And there we go. There it is. So I've plotted the points, and there they are. Oops, there, that fits better. Okay, so there you go. And now, just like the other graph, it has an arrow up here going on forever and an arrow down here going on forever. And just real quick, if you wanted, you could have the calculator graph them as well. Let me go to the window. Our window went from -4 to 4, I believe, and scale of 1, which is where every tick mark is. And then it went -28 to 28, and the tick marks, or the scale was like 2 or 4. I'll just put 4 in it. All right, and then I'll graph. And you can see that it's going to match what we had, right? Like that. So, but the graph on the calculator isn't so helpful to us. What's really helpful is the table, because the table gives us points that we can use to graph. All right, we're done with that. Now we're going to simplify. So we have two functions here. We have f of x, which is equal to 3x minus 4, and g of x, which is equal to x squared minus 2, or excuse me, x squared minus x minus 5. We're going to find and simplify the following. So first thing we're going to do is f of 4. So let me bring that down here. So I'm going to take the f function, and I'm going to put 4 into it. Bring this over so we can see it. So it's 3 times 4 minus 4. That's 12, take away 4, which is 8. There we go. Done with that one. All right, that wasn't so bad. What about g of -2? All right, so we're going to have to put this in the g function. Oops, let me bring it over here. It's x squared minus x minus 5. It's just off screen. There it is. All right, so I want to take -2 squared minus -2 minus 5. And I cannot stress this enough, but whenever you are substituting a negative, always put parentheses around that value. It will help a lot. Okay, so this is equal to -2 squared. All right, so -2 squared is -2 times -2, which is positive 4. And then negative a minus 2, minus a -2, let's put it that way, minus the opposite of 2, is plus 2, minus 5. So this is equal to 6 take away 5, which is 1. There we go. All right, now we're going to be finding the generic function for f plus g of x. All right, so let me bring that down here. So I want to take f of x, and I want to add to it g of x. So let me get in here. So I want to take f of x plus g of x. Oops. That would be equal to 3x minus 4, actually I'm going to put this over here, plus the other function, which was x squared, oopsie, x squared minus x minus 5. Let's make that bigger. All right, so I want to add this function right here, 3x minus 4, that's my f of x, plus this function right here, that's my g of x. All right, so the parentheses are kind of a fake out. We don't really need them, right? But it's 3x minus 4 plus x squared minus x minus 5. All right, so now it's a combining like terms problem. So I've got x squared, there's no other x squared, so that's fine. Then I have a 3x, take away an x, so that's plus 2x. Minus 4 minus 5 more makes minus 9. And there we go. Done. All right, so now for the next one, we've got a little bit more work here. So we've got to find f minus g of 1. So we can do this a couple ways, but for practice, I'm actually going to have us find f minus g of x first. So hold on. So, oops. We're going to find f minus g of x. This isn't the only way we could do this, but I'm going to do it this way because we could use the practice. So we're going to do f of x minus g of x. Oops, not minus. Minus, not equals. Come here. There we go. All right, so that would be 3x minus 4 minus x squared minus 5, excuse me, x squared minus x minus 5. All right, so that's 3x minus 4 minus the x squared plus the x plus the 5. Right, we have to distribute negative. Right? So you have to make it minus the x squared minus the minus x, that's plus x, and minus the minus 5, that's plus 5. Once we're here, then it's a pretty straightforward combining like terms problem. So we have minus x squared, then we have 3x and x. Those two together would make 4x, so plus 4x, and then plus 1, because minus 4 plus 5 makes plus 1. And there we go. Oops, I better not box that because that's not actually the answer. Let me underline it. Okay, so now what they really wanted for us to find was f minus g of 1, which means we're going to take that function and put 1 into it. So 1 gets squared plus 4 times 1 plus 1. Okay, that would be equal to negative 1 plus 4 plus 1, which last time I looked was 4. And that's our answer. So that's what'll get the box. Good, done with that. All right, so last but not least, a story problem. So first thing we're gonna do is find r minus c by hand. So hold on one sec. All right, so oops, let me just go over what this is. The revenue and costs, both in millions of dollars for Southwest Airlines at T years since 2000, can be modeled by these functions. Now, in case you haven't been in business class, revenue is the money you take in sales, and cost is the money you spend, right, to keep the airline running. Okay, so we're going to find an equation for r minus c by hand, which is what I've done right here. Well, I haven't done it yet, but we're going to be finding it. So we're going to find r of t minus c of t. So you're going to take your revenue, your money coming in, and take away your cost. Now, if you're running this company well, this should be a positive thing, right? Because you want to take more money in than you spend. It should work for your budget and your house as well. All right, so we have 183 t squared. Why am I typing this? I don't know. All right, so 183 t squared minus 581 t plus 5964. Now I'm going to distribute my negative because I need minus times all of these things, right? So let me remind you, distribute negative, right? Okay, so it's going to be minus 102 t squared. That one's easy. And then the next one is minus a minus 100. So that's plus 100 t minus 4897. All right. So now we're going to have to combine some like terms here. All right, so we take 183 t squared and we take away 102 t squared. That would be 81 t squared. Then we have minus 581 plus 100. Wow, these are numbers that are easy. I can do this in my head. Right, so if you have minus 581 plus 100, that's minus 481 t. So those ones go together. Maybe I'll underline them so you can see them. So this one, oops, well, that'll work. This one and this one go together. Okay, and then we've got the two numbers, the 5964 and the 4897. I can't do that in my head, so let me quit. Oops, hold on. Okay, what was that? 5964 take away 4987. That's 977. So plus 977. There's our function. All done. Okay, then it wants r minus c of 10. So you take 10, put it into your function. I typed it in the calculator and I got 4267. So 4267. There it is. Now I got to type up what it means, but we're at the end of the video, so hold on one sec. There we go. Revenue minus cost is equal to profit. So the model is predicting that the Southwest Airlines company will have a profit margin of about $4,267 million in 2010. And we're done. See you here for the next video.